Okay. Let's see. I don't know. Remind me when this is done and I'll put it up there. Just in case. Because I don't remember if I did or not. Alright. So. Any thoughts on what we might have to do with this problem?
Flip it.
Flip it.
That's all I got.
And then separate them?
Potentially. We might, I think we can do it without actually doing that, but we do need to flip it first to do that. So, negative, or well, I think we need to, we're gonna flip it, because I'm pretty sure it needs to be in this order. Yeah. Okay. So now we're going to do this, and since we have an x in both pieces, we're basically going to do it how we usually do, like the top part minus the bottom part, you know, like when we've solved an integral, like we do the top minus, okay. So basically we're going to do that.
Okay.
And then that negative sign out front will get multiplied through everything when we're done. So the negative is just going to be out here for the moment. So this first piece, let's do it for the 3x squared part. So if we plug that in here, we would have ln of 2 plus 3x squared squared times, what's the derivative of this piece?
6x.
Times 6x. Then minus, okay, so this would be like when we do the bottom dimension, since they both have one. Minus, we're going to replace here. So this would be the ln of 2 plus 5x squared times, what's the derivative of 5x? 5. So then now multiply this negative through. So we're going to get negative 6x ln of 2 plus 9x to the 4th. Negative through this part, so plus 5 ln of 2 plus 25x squared. And the book is inclined to flip the answer and do this part first just because it's positive, and then do the minus that part, but that would be how you would do it. We probably technically would have gotten the same answer if we had left the dimensions originally, but it's better just to get in the habit of flipping it just so that when the ones that it needs to be on the top, you have it on the top. Let's see. Construct a function of the form. I'm going to write this just because that way we can see it. Of the form y equals the integral from a to x of f of t dt. This is a different one, different instructions.
Oh, so we finished that problem?
Yeah,
Oh,
that would just be left there.
that feels so wrong.
Yeah, there's nothing else we could do with it.
Okay.
Yeah, it looks weird, but that's all we could do with it.
Is that integral of a to x?
Yeah. Okay, so one, and then that satisfies the conditions for the actual problem. So, like problem 22, dy dx is equal to e to the x tangent of x. Y is 0 when x is 8. So basically, whatever this y value is going to be the plus c part, and whatever x is going to be the bottom dimension or parameter on the integral for these. So this is going to become the integral, or I guess y equals the integral from 8 to x e to the t tangent of t, okay, because it wants everything with respect to t here, dt. And this would be plus 0, but we don't really need to write that, obviously, because it's just 0, but just for reference for you, for, like, looking at them. Let's see, 24. dy dx is equal to the square root of 3 minus the cosine of x. Y is 4 when x is negative 3. How would I set this one up?
Y equals the integral from negative 3 to x, the square root of 3 minus cosine t
Yep.
dt plus 4.
Yep.
That's all I do.
Yep. This section seems like oddly easy, if that makes sense.
Yeah.
Like, there's a few things that'll get a little more in depth here in a minute, but not still super crazy. Do we need to see another one like this, or are we okay on this?
I think we're fine.
Good.
I'm fine.
Pretty much just replace x with t, and whatever x is the bottom, whatever y is the c. All right, evaluate each integral using part 2 of the fundamental theorem. So let's look back at that really fast. Maybe. So the fundamental theorem of calculus part 2, if f is continuous at every point from a to b, and f is any antiderivative of f on a to b, then we have the integral from a to b of f of x dx is equal to f of b minus f of a. So basically, we're going to be showing that that's true. Okay, so 28, we've got the integral from 2 to negative 1 of 3 to the x dx. Do y'all remember what the what the antiderivative of this would be? Like the reverse. This would be the one that's a to the x.
Is the x ln of x.
So we have to write it like
I'm trying to remember if this is one that you actually already know.
We know the derivative of this.
It's ax to the ln of x.
because the derivative was
Yeah, this might actually be one that y'all don't know yet.
here the x ln.
y'all don't know this one yet. I don't know why it's in this section. Okay, I'm just going to tell you what it would be. You'll learn it later. We'll learn like a bunch of the antiderivatives of things later. This is going to be the integral from 2 to negative 1 of 3 to the x over the ln of 3. Or I guess I don't. I wrote this wrong. You shouldn't have the integral here. It would be like that. I'll show y'all what that table is later. Okay. So then we would be evaluating this from 2 to negative 1. Would you agree that 1 over the ln of 3 is just a number? Okay, so I can take it out. So 1 over the ln of 3 times 3 to the negative 1 minus 3 squared.
Wait, what did you do there?
I just took the ln of 3 part, the 1 over the ln of 3 part out so that I wasn't having to deal with it. And then I replaced x with these parameters. Just doing it this way. Somebody multiply that through and figure out what that is. Yes.
Okay, that's negative 7.89.
And they leave it as negative 26 over 3 ln of 3 or that, so either way would be fine if you chose to leave it there. Why is this so blurry? Okay, let's do one that we actually know the antiderivative of, because you haven't learned these yet, so that one.
It does make sense though, because the derivative of it is multiplying of the antiderivative.
Yeah, they make sense, but like you don't know it yet.
Yeah.
I wouldn't expect you to know that yet, if that makes sense. Like I try to remember, and I'm like, wait a minute, no, they know the derivative, not the antiderivative. There's a whole table in the back if you want to write it down. It's page 620. That has I say table. It's not really a table. It's kind of mass chaos, but it's a whole bunch of integrals from like 620 to like 623 or something like that. There's a whole bunch of integrals that if you are ever looking for one and you don't know it, they're there. Okay, so let's do one that we actually know. 30. The integral from 0 to 5 of x to the 3 halves dx. Or one that we would know how to find, I guess I should say. So I need the antiderivative of x to the 3 halves. How would we find the exponent that's going on it?
Subtract 1 from each other.
Yep, add 1 to it. So this would be x to the, add 1, so add 2 over 2, so 5 halves. So then what number has to go in front for that to cancel? 2/5. Now, just like I had the 1 over the ln of 3, I can do the same thing with the 2/5, pull it out front for when I multiply it. I mean, if you don't, that's fine, but just to make life easier. So it's going to be 2/5 times 5 to the 5 halves minus 0 to the 5 halves, which you wouldn't have to do that part, obviously.
Do you have to put the line thing? Or can it just,
Are you saying this?
yeah.
I probably should. You want a cookie point, don't you?
Is that one?
Yeah.
You should just combine your classes.
That would be 2. That would be 2 cookie points.
Hey, better than one.
And we're still
Huh?
not, we're still with that. Because I would have to. You said how many cookie points?
Because they have ways that they can earn them. I have to motivate that class with food.
That's the first period, right?
Yeah.
Oh.
Some of your teammates.
Okay.
I'll be like, if y'all get this right, you can get a cookie point. They're on it. Ethan's like, that's not fair.
I mean, you kind of did the same thing for us last year,
Mhm.
but it wasn't that.
Y'all were like less food motivated though.
It was, I mean, we were just, I mean, I couldn't care less. But if I saw a mistake, I would say.
Yeah, well, I'd rather it get pointed out instead of like, waiting till the end. Like today, we entirely used the wrong trig function and didn't realize it till the end.
I like when Josh used the wrong formula.
You weren't even there, so.
I know.
Like we had this.
I was there.
It was like a triangle like this, right? And we had this side and this side, right?
I watched the video.
And I was like, all right, we need to solve, or we were trying to solve for, y, for example, okay? And Will was like, use sine. And I was like, okay.
That's not slide.
That was awesome.
We got all the way to the end of the problem, and I was like, something's wrong. Before realizing it should have been tangent. It's fine. And no one else bothered to say anything. Just let me roll with it.
First time.
They probably
You should have known, because Tristan acquired it.
He'll usually tell me, he'll be like, shouldn't it be this though? And I'm like, yeah.
Yeah.
He's got it under control though. He knows. It just depends on if he decides to tell me or not. He was like, yeah, I didn't think that sounded right. I was like, then tell me. All right. What's 2/5 times 5 to the 5 halves? 22.4, or the book will also write it as 10 square root of 5. So that sounds like a lot of work to me.
Sounds unnecessary.
So it
So, anyways. Little harder. 34. Not as bad as the first one. From 0 to pi of 1 plus cosine of x dx. So I need antiderivative of 1 plus cosine x.
is sine somewhere.
Hypothetically. What else is in there?
So next.
So x minus plus sine
X
Why is it minus?
plus.
plus sine.
We were thinking the other way around.
Just to check, I did give y'all your quizzes back yesterday, right? Did I?
Yes.
Okay.
Yeah.
I couldn't remember if I actually gave them back or not.
Wait, so okay. So these sections are just good.
Oh, the same.
Just going back to like 6 school.
Pretty much. There's different ways that you can do different problems, but it's kind of like if one method's working, just
Stick with it, yeah.
basically. So this would be pi plus sine of pi minus, don't forget, and there's multiple pieces, you need to put parentheses around it, 0 plus sine of 0 What's sine of pi?
Sine of pi is.
Y-axis.
Wait,
Oh, wait.
where's
Yeah.
pi?
I
No,
know, it's
pi's on this
x-axis.
side.
Yeah.
Yeah,
That's the cookie point.
it's zero.
Yeah.
It is zero.
That's
Yeah, it's
like-
zero.
That's another
That's
one.
another one.
What's the sign of 0?
Sine of 0 is.
One.
Are you sure?
I am
Yeah.
so
No. Thought it was
It's
0.
zero.
It's 0, guys.
Zero.
The x-axis.
I know.
It's
That's
1,
literally
0.
what I just said, guys. Come on.
X-axis.
Come on, Nathan.
We
What
need
are
to
you
use
doing?
the quiz.
Yeah.
Okay.
Alright, so minus 0 for all that, so it's just pi. Yeah, clearly we do.
Apparently.
Yeah, all.
With just x and y values in radians.
I'm
Yeah.
just mixing up my sign and cosine.
Can we not have
All
it this
six
week?
of
Because I
us.
don't have enough time to take another quiz.
Yeah.
Girl, I don't have enough time for any of that this week.
Oh.
I have to do a bulletin board in the hallway.
Did you do that? I know you probably still have
Now
to
that there
take-
might be a game here tomorrow, that just like throws
Yeah.
everything for a loop for me.
Speaking of
What
that,
day you leave?
Thursday at lunch.
Thursday at one.
speaking of testing quizzes I have to take, I think I'm more ready for the calculus test than I am the stats quiz. So could I possibly take the calculus test tomorrow instead of and then do stats Thursday?
What are you doing, physics?
Thursday.
Okay, yeah, that's fine.
I mean, I could probably
The physics test is done,
probably do physics tomorrow.
but there's a physics quiz tomorrow in section 3.
I could do the quiz in the morning and then. Oh wait, no, I can't do that. Because it depends on if we win today. If we win today, that could throw up our whole plan.
Oh yeah.
Because I would have to take calculus probably in the morning if we win today. I guess we'll see if we win, and then we'll figure it out. I'll figure it out. Or I can just do everything Thursday, I guess. That sounds awful.
By the way, not that you'll be here, but on Thursday, I gotta leave physics early. Cause I got a hair appointment.
You have to leave what early? Physics?
Yeah.
Okay.
I got a hair.
Okay. Are you gonna be here for some of it, just not all of it?
Yeah, I'm gonna leave it around. I'll be there for like half a class.
Okay. I'm just gonna leave a note for the sub, so that they know. I need to remember.
I get here at
I have to
7
tell y'all
on
something
Thursday.
about the physics test today. So
Okay.
just don't let me forget when we get to physics class that I have to tell y'all something.
Okay.
Because if not, you'll be really confused when you get the test on Friday.
Oh.
Oh.
That's not good.
Especially since I won't be here. Oops. Alright. Integral from pi over 6 to 5 pi over 6 of cosecant squared theta d theta. This is one we know, right?
It is.
Okay.
Yeah.
Just making sure.
It is.
It's cotangent, right?
Negative cotangent.
Yeah, it's negative cotangent.
Negative cotangent of theta from pi over 6 to 5 pi over 6. Now y'all really gonna need a unit circle.
Really have to rack on. It's okay. It's okay. I think I can.
Alright, minus the cotangent of theta. Nope, cotangent of 5 pi over 6. Plus cotangent theta pi over 6. Like, watch now. You'll already have 2 cookie points.
Okay.
The rate we're going.
Wait, were you supposed to put the theta there?
Gosh.
Yeah.
Ouch.
Glad I didn't combine your classes. Go broke. College algebra's gonna be like, how'd they go from none to 3? Feel like you don't want to know.
Integral.
Ooh, baby, a triple.
What?
Easy.
All right, what's the cotangent of 5 pi over 6?
So we gotta think of it as 1 over the tangent of 5
I don't remember that
If you
side.
get it wrong, I get a cookie point taken away.
Whoa.
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 Hey,
Whoa.
we did
It's
not
not our
agree-
fault
we did
you
not
put the
agree to
theta.
this. I don't even need the unit circle. Watch this.
Okay.
Babe, don't do it. Don't do it.
You dare.
So the tangent of 5 pi over 6 would be
Wait, do pi over 6 first, 'cause that's easy.
right.
I mean,
So it's
big
root
there.
3 over 3, isn't it?
Yeah.
So 1 over root 3 over 3.
Ew. That's gross. And then.
You gotta rationalize that puppy.
Could you like
Aw.
3 root 3 over 3? So it's root 3.
There's 3.
I'm good now.
Oh, no, it's just root 3.
Yeah, root 3.
It's just root
If you like simplified it.
Is that the final answer?
3. For cotangent pi over 6.
Yeah,
yes.
yeah, for cotangent. Now wouldn't it be that for
Oh yeah, wait. I don't even know what.
what does that be for both?
Well, the other one's
It would be negative root 3.
But then there's a negative sign in front, so it would just be positive.
Wait, this is
So it'd be-
cotangent, so actually I don't know.
Negative
Tangent is
root
1
3
over tangent.
Well,
It's 5 pi over
Oh.
6, so cotangent already negative. And there's a negative.
it's the
both
same.
sides, so
Well,
positive.
it's since
If
it's
it's positive.
pi over 6, and it's what root 3 over 3 at pi over 6. It
Yeah.
should be the same.
Yeah.
Just
Yeah.
you know what I'm saying?
Yeah, I know what you're saying.
So what is the answer?
Is it just root 3 plus root 3?
Negative root 3.
No, it's positive
Wait,
because
okay, yeah, it's
on the
yeah.
final-
All right, is it positive or negative?
Positive.
Positive. Ah,
Now what does that equal to?
that was a lot of mental
2 root
2
3.
root 2 root 3.
I was gonna see if y'all were gonna tell me it was square root of 6. Had some classes do that in the last week.
Not us.
Yeah, you almost sold it
Wait. But
I was just
Now-
speaking my thought
for it. You was
process.
thinking.
In case you need a little reminder here, okay? These are the tangent values on the outside, right?
Yeah.
So what do you notice about the pi over 6 and the pi over 3s compared to what you just found?
It's flipped.
They're flipped. So if you know the tangent of pi over 3, you know the cotangent of pi over 6.
What do you mean they're flipped? Where'd the extra 3 go?
You flip it, but then you can't have a radical at the bottom, so that's why you have to do
No, 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 no. You just flip them.
Oh, where'd the other 3 go?
You rationed it out.
The cotangent here would be root 3. The cotangent here would be root 3 over 3. You can just flip them.
No, but I'm so confused. How could the cotangent be root 3? Because where does that 3 go?
Okay, 1 over root 3 over 3
Yes.
is 3 over root 3.
Yeah.
Times root 3 over root 3, which is 3 root 3 over 3. 3's cancel, and I'm left with root 3.
Okay. Thank you.
We said
We
like
were
3
talking
times.
about that.
We had a whole conversation about it.
We were talking about it.
I
and
didn't
we never got
understand
written
anything
down.
y'all were saying. All I
Always-
heard was root 3, root 3,
Yeah, we
root
were
3,
saying a
root
lot of
3,
shit.
root 3.
All we said was rationalized.
You
Y'all
expect
doesn't
me
know
to
what
know
that
what that
means.
means?
You should know what that
Is
means.
Don't know what that means.
It means that.
It's okay,
Well,
guys.
now
This,
I
is
know what it means.
this is why we're doing practice. Maybe I should just do this one that I was going to skip. The integral from 0 to pi over 3
Sorry, stupid.
of 4 secant of x tangent of x dx. 4 secant of x from 0 to pi over 3. Because there was a 4 out front. So, again, I'm going to take the 4 and pull it out front. Because I can. It's a secant of pi over 3 minus the secant of 0. So, what is the secant of pi over 3?
Okay, initial term.
No, it's not.
Christians.
I think Christian should contribute something here.
So secant is 1
I help us.
What? What'd you say?
Nothing.
Nothing.
You're not helping.
Anyone?
Secant 1 over sine?
Secant
Wait,
is-
no, I didn't hear what he said.
I said
Cosine.
1 over
Yes, okay.
Yeah. Okay, you said no, so I was confused.
No, I didn't say no. I said, what did you say? And then he said, no, never mind.
I was like, that was right.
I was like, wait.
Secant is.
Because all I heard was sine. That's why, but I didn't think that's what he said. So I wanted him to say it again, and then he wouldn't.
Oh.
Two.
Does everyone agree?
Wait,
Wait, hold up.
wait,
Hold up.
no.
Cause secant.
Hold up, so if you
You're
think
saying
about it,
secant pi over 3?
cosine of
Let's
pi
say
over
let's say
3
we
is-
sine pi over 6.
I
So,
agree.
wait. Let's say it's sine pi over 6. So it's 1.
It is 2, because it'd be 1 over 1 half, and rationalized.
Okay, that's
Why
not
are
the
you
same-
rationalizing
That is
that?
not the same thing as
Don't
rationalizing
That's
it.
not, yeah. Okay, Josh,
But like,
you don't know, you know what it
thing to
means
get
now.
the 2.
So 1 over 1 half would be keep, change, flip 2. The flipping thing works with cotangent and tangent, nothing else.
Huh?
The flippy thing.
All right, what's the secant of 0?
One.
Sure?
Yes.
Okay. So what's the final answer?
4.
See if I was going to trick you.
I did it.
John? Do you want a cookie?
I mean, I do.
I can give you a round of applause.
No. I don't have a cookie.
Why'd you offer?
She didn't offer. She just said, "Do you want to?"
Yeah, I just asked you.
Yeah,
One
she
more.
offered.
That's not an offer. It's not an offer.
It's based off of assumption.
You know what happens when you assume? You make a out of you and me. That's what my mom says.
Nothing.
A lot of things.
What did you just say?
Thanks for getting cookies when the entire class reads them.
I said, what happens when you assume? You make a hee-haw out of you and me.
Make them. She offered.
You make a
What happens when you assume?
I'm getting some of those on Friday. I'm so excited.
what?
Because I'm going to New Orleans.
What are you getting?
Beignets.
Beignets.
What are those?
Have you ever seen
Delicious.
Princess and the Frog?
Wait, what did y'all say?
They're French donuts.
And they're called what?
Beignets.
Yes.
Beignets?
What?
Maybe
Beignets.
Maybe I need to fly some back
I
with
never
me
heard
to
that.
New York.
It's
have like this
it's
something like-
literally it's just a donut.
Y'all have tried that?
It's like, okay, think of like a funnel
They
cake
don't look-
in square form, but fluffy.
Yes.
That is not helping me.
They do not.
They don't have a hole in the middle.
They do not look like donuts, honestly.
Just look it up, Josh.
It's a French donut.
Okay.
Dude, gotta be French.
I'm not French.
I ain't never seen that in my life.
Have you ever seen
Those look like
Princess and the Frog?
tortilla pizza rolls.
Wait, let me
without
see.
a
That was
sugar.
actually.
They're not.
That was
What?
actually kind of-
Did you say tortilla pizza rolls?
What's a tortilla pizza roll?
Are you looking at the right thing? Because it does not look like.
The Tostino
What
pizza rolls.
It does. That kind of
The
does.
That's a
Tostino
baby
pizza
egg.
rolls. Not the-
Tortilla pizza roll.
These ones kind of do look like pizza rolls.
About Rondo.
When they're done at Cafe Du Monde, they're not like a pizza roll.
Cafe Du Monde. Don't know what that is.
You've been there, right, Ethan?
Cafe Du Monde. I've been there like once, maybe.
Okay, but you know what I'm talking about.
I haven't been down to Nolans area.
Yeah, neither have I.
What Dang, okay.
Okay, we're gonna do an example.
Have we not been doing examples?
No, like from the
Oh, okay.
Are these all from the book?
Wait, yeah.
not from the homework, Nathan.
Oh, okay.
There's only like 3 problems in this section, so I'm trying to find another one that we can look through before we do that one. Okay. Find the area.
We're stressing her out. Area.
Oh no, the bell's gonna ring. Of the region
Oh my goodness. The top 5.
between the curve y equals 4 minus x squared from 0 less than or equal to x less than or equal to 3 and the x-axis.
What did you say it looked like? Hey, you said
Like
A Totino's pizza roll.
Toasty
He said
pizza
tortilla pizza.
Well, yeah.
roll. Wait. I meant to say like the toast, you know, the Tostino pizza rolls.
there's no S in it.
Totino's.
It's Totino.
Oh, I thought there was an S in it, not gonna lie. There's tortilla though.
That's exactly.
wait, there's no S in it?
It's not Tostinos.
It's a man thing.
That's something different.
Oh, man, no.
Everybody thinks that. There's no S.
Oh my gosh.
Yeah, isn't that like Tostino's pizza?
There's Tostitos. And then there's Totino's pizza rolls.
Tostitos are the chips.
Tostitos.
Yeah.
Okay, I'll get through this.
Okay, so first thing we need to do, okay, we're on the area 0 to 3,
Okay.
okay? This is between the curve. What shape is this?
Parabola.
Okay, parabola. Okay, may or may not be the whole parabola because we're just from 0 to 3.
That means parabola, don't it?
And the x-axis. Okay, so basically, okay, rough sketch, right? It's gonna look something like this. I don't really know, not exactly. Just
That's not nice.
bear with me, okay? So from 0 to 3, okay, so it's this region here that we're finding the area of.
Okay.
Okay, basically. That's just a rough sketch so that you can visualize. Okay? So, what I'm going to do, I'm going to set this equal to 0 and see if I need to partition it at all. Okay?
Right. Does partition mean like break into parts?
Yes.
So
So,
it just gave that.
4 minus x squared equals 0. So, x squared is equal to 4.
Negative x squared.
No.
Wait,
What?
Minus 4 divided by negative becomes positive.
Better percent.
So, x equals what?
Two.
Or
Negative 2.
plus or minus. However, I'm on 0 to 3, so I only need the positive one in this case, okay? That won't always be the case. So that means that the curve crosses the x-axis at 2, is what that's telling us, okay? So my picture's obviously not drawn correctly because I have it going out farther, but I was trying to give you a rough visual. So now what I'm going to do is I'm going to partition the interval. Zero to 3 into 2 subintervals. Okay, it could be more or less in some, oh, not less, but could be more in some cases. Now, when I break them, they're not gonna, the value of the function will not change sign when I break them up. Okay, it'll be like our increasing and decreasing almost kind of thing. So we are going to look at the interval from 0 to 2. Which is going to be the integral from 0 to 2 of 4 minus x squared dx. So what is the antiderivative of this?
4/4.
1/3 x cubed, evaluated from 0 to 2. So that's going to be 8 minus 8 over 3, which would be 24 over 3 minus 8 over 3, which is 16 over 3. So I'm going to circle that just so I don't lose it. That's part 1 of the area. The other part of the area is going to be the interval from 2 to 3. So I do the same thing, but I integrate from 2 to 3 instead. So I still have 4x minus 1/3 x cubed, because that didn't change. I just now evaluate from 2 to 3. So I've got 12 minus, what is that, 27 divided by 3, so 9, minus, I would bracket this part off so you don't get the signs wrong. We've already evaluated it for 2, right? Because this value up here, we didn't have anything for 0, so this number is 2. So I can basically get out of having to do it again. So then this is 3 minus 16 over 3. So 9 over 3 minus 16 over 3 would be negative 7 over 3. Now, can area be negative? No. So when I go to add them together to get the total area of the region, I'm going to do the absolute value of 16 over 3 plus the absolute value of negative 7 over 3, which is going to be 23 over 3. And that would be the total area in that region. Negative is just telling us that it's below the x-axis, is all that that's telling us in that. So we'll look at 1 or 2 tomorrow from the actual homework problems, and then one other thing that we need to do with this section.
Never mind, I'll take the